Yeah, so you're going to hear from myself and Phil Pollard. We both work for, I'll say, North Carolina DOT, and we are in the GIS unit on a team that is responsible for maintaining our road centerline and linear referencing system. So we're here to tell you about how we're using OpenStreetMap, and the way that we're currently using it for our purposes is through something we call the Integrated State Road Network, or ISRN, which is a conflation between OpenStreetMap and the North Carolina DOT road centerline. So go ahead, Phil.
Oh,
There we go. So what we were thinking is that I would give y'all a quick overview of the North Carolina DOT road centerline and also explain to you what linear referencing is, because if you're like me, I didn't know what it was until I joined a DOT. And then I'll turn it over to Phil, and he'll talk about how we're leveraging OpenStreetMap through a conflation, because there's two different data sets. We've got the OpenStreetMap centerline and we've got the North Carolina DOT centerline. They're different. And so what we do in leveraging OpenStreetMap is we conflate the two and we produce an output product called the ISRN. And we've also built a bunch of tools that support data quality. So through our conflation, we're able to compare the two different data sets and identify areas of improvement in data quality in both. And so we are using that information to not only update our NCDOT centerline, but we're also updating OpenStreetMap. And if we have time, we'll share with you some of our ideas for future uses, because we're only scratching the surface. There's so much information in OpenStreetMap and so much potential. We foresee a lot of benefits. So if we have time, we'll get into that. But go ahead, Phil. Also, real quick, hopefully real quick, this is a screenshot of a one-pager that we have written on what linear referencing is. So linear referencing system, LRS, synonymous. Don't worry about the text. It's probably hard to see. I care that you see the pictures here. And so what's important to us as a DOT is important to all DOTs. It's important to every territory. A linear referencing system, if you can imagine on the picture on the left, a road in the real world, it's got assets and it's got road characteristics along it. So assets, you can see a guardrail, you can see signs. Along the road itself, you see line striping. You can tell if there's a median or not, if there's shoulders or not, if there are turn lanes or not, what type of pavement it is. That's all stuff a DOT cares about. And so the way that we reference that in a virtual environment, a mapping environment, a GIS environment, the same as OpenStreetMap, we represent a road as a linear feature. In a linear referencing system, that linear feature becomes what we call a route in a route network of multiple roads. And if you can imagine turning that route into a ruler or a tape measure or like a yardstick or something, anything that has a system of measurement, that's what a linear referencing system is. So you have a start of your linear feature, which we say usually starts at 0. And if you go along that feature, you're traveling some distance in some unit of measurement from the beginning of the feature. And so in our case, we represent the unit of measurement in miles. And so we say whatever asset or whatever road characteristic starts or stops at this distance in miles from the beginning of the road. And so this is important because, like, if you can imagine in OpenStreetMap, I don't know if you can see my hands, but like if you have a segment that goes between one intersection and another, that's one segment of centerline. And if you were adding a tag to that in OpenStreetMap, it can only be one discrete entry. So speed limit is only 45. Pavement type is only asphalt. However, in the real world, it's probably not true between every intersection. And so if you wanted to represent all of those characteristics or assets along that linear feature, you're going to have to segment your road, right? So if intersection to intersection is this distance and your speed limit changes from 45 to 35, you're going to have to segment. So here's the 45 and here's the 35. And then if you take like, we have like 80 road characteristics, however many assets, and you want to reference all that to your road center line or your linear feature, you're going to have like tons of segmentation. And so the benefit of linear referencing is that you reduce the need for segmentation, and you can show a location in units other than like XY coordinates or lat long. You can reference them all to the same system of measurement in a linear referencing system. So that's why DOTs, like I'm speaking on behalf of North Carolina, but probably other DOTs would say the same thing. Like they care that we have a linear referencing system, which I don't know of a way to do that with OpenStreetMap right now. And being a government entity, we love COTS products. I don't know that there's a way to do that. Now we could maybe leverage centerline data, but to make it a linear referencing system is a whole nother thing. So hopefully that makes sense. If you have questions, I can try to answer them after the fact, but go ahead, Phil. And so I bring that up because I'm saying we have two different data sets, but we're using OpenStreetMap and we're a government agency. So talking about whether it's authoritative or not, put all that aside. What we need to do as North Carolina DOT is satisfy a whole bunch of requirements. And so some of them are federal requirements, some of them are state requirements. There may be other requirements I don't even know of, but in terms of federal requirements, you heard Sean from Arizona DOT mention HPMS in the introductions. So every DOT, every state territory on an annual basis is mandated by the Federal Highway Administration to submit a report called HPMS. And as part of that, we have to submit a linear referencing system. So that's one requirement there. And then on a state level, in North Carolina, we care deeply about route numbers, not street names. Street names we see as a local government thing. We care about route numbers. We also care about the roads that we own. We don't necessarily care if it's a private road. We care to know that this piece of pavement is not owned by the state. But we need to track that in our road center line. We need to know what roads we own and we are responsible for spending taxpayer money to fix or maintain. And we also care about the length that we are responsible for maintaining. So an example, like a road that it may dead end, but we only as a state agency are responsible for maintaining 0.6 miles of it, and the remaining 0.4 miles are private. So we don't want to spend taxpayer money going and fixing a pothole in something that's not our piece of pavement. And something else to bring up of why there's a difference here, like our classification, the classification of roads that we care about is very different than like the OpenStreetMap classification that's based off a European route model. So we care about what we say are primary or secondary routes and what we say are on system or not on system. And so we have route classes broken out by interstate USNC. We say those are primaries, they're more major roads. Then we have secondary routes. You'll hear Phil talk about secondary routes or SRs. Those are state maintained roads, but they're more minor roads, but it's a big portion of routes in our state. We have non-system roads. Those are other public roads, probably maintained by like a municipality, but they're not the responsibility of the state of North Carolina. And then there's other classification schemes within this setup. So we have route class. We also have functional class. This is another thing that every state is responsible for. It's just another classification scheme important for planning. But just to show you, there's a difference here between what we care about and how OpenStreetMap classifies routes. And so I bring this all up because we want to leverage OpenStreetMap. We want to work with OpenStreetMap. At this point in time, they're discrete data sets. Our DOT data set is very different than the OpenStreetMap. The way we model it's very differently. In the future, that could be different. I'm trying to level set for today to get into why we're doing what we're doing at this point in time. But I do hope over time, any mapping company, OpenStreetMap, like we can all start to come together with how we model roads and share information back and forth. So hopefully that is enough of an introduction to get into what Phil's going to share about how we're using OpenStreetMap through that ISRN conflation for now. with future plans to see how we can take this forward moving forward. So go ahead, Phil.
Okay, so what we're going to get into would be the route class that's on this slide. Uh, and that's the most important thing that we're going to overlay on the OpenStreetMap center lines. And so the ISRN is, we called it the Integrated Statewide Road Network. And a lot of business units and a lot of companies are using OpenStreetMap center lines uh, to conflate their data on top of the center lines. And so we decided to put the route ID from ours, which is an 11 digit, and the beginning mile point and the ending mile point. So the ISRN is a conflation between the OpenStreetMap centerline, and we are overlaying the NCDOT LRS routes across all roads. In early 2020, what I said before was that there are some companies that were doing conflation with OpenStreetMap center lines. So we decided to do a Python script, and we thought that it was a good conflation for it. And we moved forward from that. And like I've said, we've uh, transferred the route ID and then the beginning and ending mile points onto the OpenStreetMap center lines. So the benefits of the ISRN is finding locations where updates may needed in the NCDOT LRS center lines. And, you know, sometimes the divisions don't send things to us to let us know that there are projects that are completed. But we found in OpenStreetMap that we can leverage that into our LRS. So the completed projects, you know, we're not aware of that have been completed. There's dual carriageways, which uh, which is 200 feet long, and we're not reported uh, from us, but we can see it in the OpenStreetMap. So we're doing comparisons in some of the scripts. Uh, there's intersection discrepancies, and I'll show you some of those in a few minutes. There's also roundabouts, and there are a lot that are being created in North Carolina and probably everywhere else in the country. Uh, the ability to support data transfer from one data set to another, from OpenStreetMap to LRS, and then LRS to OpenStreetMap. Streetlight was one of the companies that is trying to use our route IDs. So the ISRN software and tools, and the two main things that we use are ArcGIS Pro and doing the conflation with the tools in that. In the beginning, number two, QGIS, that's where we download the OpenStreetMap uh, for each county or the state. But in the beginning, we used GeoFabric, and well, that was in meters, and the miles per hour were in kilometers. And so we tried to find another software that would do it, and QGIS is what we've going to now. These other tools we run, well, actually QGIS, we use the OpenStreetMap plugin, and we've written some Python scripts to download the data and then convert it over. Uh, Number 3 through 6, we use an ArcGIS Pro, the SRN tool. That's the conflation tool. The next one is identifying dual carriageways, detect LRS issued tools, and the secondary roads. So in the ISRN implementation steps, the Python scripting tool that conflates the entire state or county. The tool performs conflation of two data sets, OpenStreetMap and NC routes, LRS across various road categories. The primaries in the beginning we used in Pro locate features along route. And uh, over time, we realized that we could do one-to-one matching. So I'm going to go into a document that we created. Uh, so can y'all see this document? Um,
Yes, we can, Phil.
okay. So we identified what, because of the European model, it does not match our NCDOT LRS in the categories. So we queried out on motorway and all of these segments that would match our, or not match, but the roads that we needed to conflate. So we went through the motorways, the trunk, the categories, and the motorways are like all interstates, some US highways, some NC highways. And in the beginning, we were doing locate features along route, which has a buffer distance. Well, it can pull in other roads that could get a duplicate, or not duplicate, but a route ID that would not be on that road. So let me go back to the PowerPoint. And then the secondary roads are conflated by one-to-one matching. If the values are in OpenStreetMap, and if they're not, then we use locate features along route, which that is our primary concern right now, to try to populate the secondary roads in OpenStreetMap with the unsigned ref. And then there's other roads in the LRS that are conflated using locate features along route. So the output is the ISRN is a feature class which contains related route attributes and values. So we're using the open OSM ID, the name, which is the name of the road, the highway, which is the category, the max speed, the speed limits, one way, the reference or ref, and unsigned ref, and junction, which we're using right now. So then the LRS attributes we're conflating with the route ID, which is an 11-digit number, and then the beginning and ending mile point. So from the ISRN, we can do some conflation to find differences in the LRS and the OpenStreetMap that helps us to upgrade roads in our LRS. And the input feature classes are ISRN and the NCDOT LRS. And the output is identify dual carriageways and edits corrected in the NCDOT LRS system. So this is a picture that shows the median, and the purple is our LRS, which has a single road. And the yellow is the OpenStreetMap line work, which the green is highlighted, and that lets the editors know that that needs to be a dual carriageway and edited. And this is another example where you can see in the middle that there's a median uh, and then NC57 SR 1322 that needs to be divided on each side. And then we have another tool that's called Detect LRS Issues tool. And the ISRN, the conflation tool, the output, and the NCDOT LRS. And it identifies primary and secondary route changes that we have not received from the field, and edits are corrected in the NCDOT LRS system. So this picture, the yellow is OpenStreetMap, um, and the purple is the LRS. Well, this SR has not been relayed to us to take off the system because of it looks like a school really that's not been taken off the system. So this identifies what we need to take out of the LRS. This roundabout, you can see the highlighted roads, that's in our LRS. It has not been relayed to us how this has been changed over time. Uh, well, this picture kind of shows OpenStreetMap. There's differences in the line work between OpenStreetMap and the LRS too. This is another change that was not relayed to us, and we're identifying these to where that intersection needs to come together. Uh, this is another construction project that has not been relayed to us. And then this highlighted, that was the existing one, but it needs to be changed in the future. And this is another photo, shows there's a change. So now the next tool is our secondary road report tool, which is we just use the OpenStreetMap download from QGIS for county or state. We can do the whole state, and then we use the NCDOT LRS. You can see changes between OpenStreetMap and NCDOT LRS secondary route changes, and the editors will make changes to update OpenStreetMap. And ISR2 will have a one-to-one match when the edits are made. So I'm going to show an Excel spreadsheet from that report. And this identifies for us from the NCDOT LRS how many secondary roads need to be uh, in the OpenStreetMap, or comparing each other. So the orange is completed, that we've gone into OpenStreetMap and populated the SRs. So this total, like for Cabarrus, is 852. Well, an editor has gone in, and we are looking at the unsigned ref in OpenStreetMap and take the total, and we can see that somebody has gone in there and edited it. And actually, we also report in this document the ref, which we were told from somebody in OpenStreetMap not to put SRs in the reference field. And so we were told to put them in unsigned ref. And this report also shows that the NCDOT LRS like Carteret 504, well, in OpenStreetMap, there's only 21 that have been identified. And if I can go to hide, which the purple are editors that are already getting into these counties and updating OpenStreetMap. So if I click on hide, so the route name is from the LRS, and this shows the blank that there's the unsigned ref, which there might be a match, but we still have to look at it to make sure that it's correct. And then it can also tell us that SR 1149 is not in the right place. And then if I go down, then it can tell us that somebody has put in State Road 1313. So we can go back and edit that. Um, so, and this is the map uh, of showing we've already uh, done 23 counties, and the editors, when they start, we give them a small county, but we are trying to get most of the urbanized counties uh, to be completed for us to be for conflation. Oh, let me go back. So, uh, so we were worried at one time about editing in OpenStreetMap, and we were led to Elliott Plaque. And so we got with him for some of the edits that are, breaking roads and stuff. So um, this is a document that we created to go over with Elliott. And there was one thing, like for SRs, in one county, there might be 1737 on the left side, and on the right side, when it goes to another county, it can be changed to SR 1313. So we went into this, and there's a boundary right there in ArcGIS Pro. And then when we go to this in OpenStreetMap, there's no boundary. And we had to ask him about how we could get the boundary to come up. And he told us that you had to scroll down, and where there were a lot of joinings with the street map, I mean, not street map, but the boundary, then it would appear in the screen. Which, I mean, and what I'm saying is that, let me get going. Okay, so if the boundaries come together and you scroll in, then the boundaries will appear. So then we can break the road and put the SRs on each side. Um, so then the other is that new subdivisions, and we've come across some of these that we wanted to put in, but we didn't know about the attribution. And so we put these in, and the only thing that we are going to put in is the minor road classification, one way, and then the tag for unsigned ref for the SRs. We're not going to put in the road name because that's a county, kind of thing, not like a legality for us. And also we were, about primary roads like US 70, how to break that, because in OpenStreetMap, it was ran all the way across this road, but Elliot showed us how the parent relationship, we could break it and be able to do that. And I think that is about it. And then the future uses, the data quality, informing where difference exists, not as authoritative data, identify missing roundabout geometry, which that's important for us, identify missing rail crossings, speed limit issues, and street name issues, which Next Gen 911 is a state where they take the county 911 data and conflate it together. So we haven't used that at all.